A very good morning on and all. Welcome to the session number 25. Problems on LCR circuit. Problem number 1. A capacitor of 100 microfarad and a coil of resistance 50 ohm and inductance 0.5 Henry are connected in series with 110 volts to 50 hertz source. Calculate the RMS value of the current in the circuit. Here we are being provided with capacitor, which is 100 microfarad, 100 into 10 power minus 6, which is 10 power minus 4 farad, resistance 50 ohm, inductance 0.5 Henry, and voltage EV is equal to 110 volts and the frequency 50 hertz. They are asking us to calculate RMS value. So in order to find the RMS value of the current, we know that I is equal to A nu over Z. EV we know, and I need to find Z. So we know in case of a series circuit, Z is equal to square root of R square plus omega L minus 1 over omega C, where omega L is nothing your XL, omega is 2 pi nu into L. Substituting the value of 2 pi nu L, we obtain XL to be 157 ohm, whereas XC, substituting the value of 2 pi nu and C, we obtain the value to be 31.85 ohm. Substituting the value for XL, XC and R, the Z is found to be 134.77 ohm. Substituting the value to find the RMS value, RMS or I nu is equal to A nu or Z. Substituting A nu and Z, we obtained the RMS value of the current is 0.816 ampere. Problem number 2. A resistor of 12 ohm, capacitor of reactance 14 ohm and a pure inductance of inductor of inductance 0.5 Henry are joined in series and placed across 200 volts 50 hertz AC source. So we need to calculate the current in the circuit, the phase angle between current and voltage, given pi to be taken as 3. So in order to find the current and the phase, the current IV is EV over Z, the same value. Find out XL, which is omega L, 2 pi nu L. Substituting for 2 pi nu L, will obtain XL to be 30 ohm. So they have been given you XC. So R square plus XL minus XC whole square is 12 square plus 30 minus 14 whole square is 20 ohm. So Z is found to be 20 ohm. Substituting in I nu, E nu over Z, 200 over 20 is 10 ampere. So the phase difference is given by theta is equal to tan inverse of omega L minus 1 over omega C over R. So omega L is 30, 20 divided by 12 is found to be 53.13 degree. So this is the phase difference between voltage and current. Now let's look problem number 3. Resistance 100 ohm, inductance 1 Henry, capacitance 10.13 into 10 power minus 6 farad. They are connected in series with a voltage 200 volts and 50 hertz. Find the current in the circuit and the potential difference across the resistor. So we have seen how to find the current, which is we'll do the same as we done in the previous two examples. I new is equal to E new over R. So substituting the value for XL and XC, we have obtained. We have seen that XL and XC is found to be nearly same, which means they are in resonating condition. So in resonating condition, R is equal to Z. So instead of substituting Z, I will substitute R. E over R. R is given as 100 ohm and EV as 200. So that gives you 2 ampere. So please note that this is valid provided XL and XC, they both are same, obeying the resonating condition. The potential difference across the resistor is applying Ohm's law. V is equal to I into R. I new into R, it is 200 into the 2 into 100 will give you 200 volts. So the voltage across the resistance is same as to your applied voltage. Now let us move for problem number 4. A sinusoidal voltage of peak value 283 volts and the frequency 50 Hz are applied to an LCR series circuit with R 3 ohm, L 25.48 millihenry and capacitance 796 microfarad. So in this they are asking us to find impedance, phase difference, power dissipated and power factor. So in order to find Z, I need to find XL and XC. XL is omega L, omega is 2 pi nu L. Substitute the value for 2 pi nu L and we get it is 8 ohm. Similarly, XC, which is 1 over omega C, which is 2 pi nu C. Substituting the value of 2 pi nu NC, we will get 4 ohms. So for A, which is Z is equal to square root of R square plus XL minus XC whole square will give you 5 ohms. So the phase difference, which is tan inverse of omega L minus 1 over omega C divided by R, which is 8 minus 4 divided by 3 will give you 53.1 degree, which is the current lags beyond the voltage by 53.1 degree. So in order to find the power dissipated, power value is given as I nu square R. So I know I nu is I naught by root 2 or E naught by Z. I naught is nothing but E naught by Z into root 2. Substituting the value of E naught, Z and root 2, we will obtain that to be 40 ampere. So that is I nu. So substituting in the power dissipation formula, I nu square R is equal to 40 square into 3 will give you 4800 watts. So the power factor, which is the cos of phase difference, which is cos 53.1 degree, will give you around 0.6. Problem number 5. So in an LCR circuit, find the value of current and power factor of the circuit. So in order to find the power factor, I need to find the theta value. Now XL, in order to find, so XL is omega L, that is we obtain 3140 ohm. XC is 1 over omega C, substitute the value for omega and C, we obtain 1.6 into 10 power 3 ohm. So the find Z, which is square root of R square plus XL minus XC whole square, the value is found to be 1540.8 ohm. So the current, which is nu by Z, which is 250 divided by 1540.8, it turns out to be 0.162 ampere. The power factor in terms of resistance and impedance is given as R over Z. R is 50 and Z is 1540.8, which turns out to be 0.032. The same thing goes. However, the e.m.f of the generator, which is E is equal to 280 sine 100 by 50 volts. Internal resistance is 2000 ohm and L is 40 by pi Henry. Capacitance 100 by pi microfarad are connected in series. Find the frequency and impedance. So we know that E is equal to E0 into sine omega t. So when we compare this equation, standard equation, that omega turns out to be 100 pi. So then to find the frequency is nu, which is found to be 50 hertz. Likewise, in order to find the impedance, I need to find XL and XC. XL, which is omega L, and XC, which is 1 over omega C. Substituting the value for omega and L and 1 over omega C, we obtain 4000 ohm and 1000 ohm. So Z turns out to be square root of R square plus XL minus XC whole square. Substituting the value for R, XL and XC, that turns out to be 3600 ohm. In problem number 7, an electric bulb is rated at 100 watts, 220 volt supply. Find the resistance of the bulb, peak voltage of the source, RMS current passing through the bulb. So we have been provided with P, which is 100 watt, and V, which is 220 volts. We know the relationship between power, current and resistance, or power, current, voltage. R is equal to V square over P. Substituting the value for V and P, we obtain the resistance of the bulb is found to be 484 ohm. E0 is equal to, in order to find the peak voltage E0, the root 2 into EV, which is found to be 311 volts. The RMS current EV over R, substituting the value for EV and R, that turns out to be 0.45 ampere. Likewise, in problem number 8, we have been provided with resistance R, inductance Henry, and frequency 300 by 2 pi hertz. Calculate the phase difference between voltage and the circuit. So phase difference is given by tan phi is equal to omega L over R. Omega is 2 pi 300 over 2 pi into 1 divided by 300. 300 will give you pi, and the phase difference is found to be 45 degree. Problem number 9. In this problem, we have been provided with the resistance and voltage, frequency and the current. Calculate the reactance of the capacitor. So please note that we have been provided with only resistance and capacitor. Therefore, XL becomes 0. So Z is equal to EV by IV, which is EV is 220 volt divided by the current measured in the ammeter is 2.5 ampere. So gives you about 880 ohm. So substituting in the value of Z is equal to square root of R square plus XC whole square. In order to find the reactance of the capacitor, so XC separate them, found to be XC under the square root of Z square minus R square. So substituting value for Z and R will give you about 85.7 ohm. Now in this question, we have been provided with the resistance, capacitance and they are asking us to find the current in the circuit. In order to find the current, find the impedance. So the impedance, since it is connected to resistance and capacitor, impedance is found to be Z R square plus XC whole square, which is found to be 291.7 ohm. The current is EV over Z. Substituting the value of EV and Z turns out to be 0.75 ampere. So this is how you need to solve the problem depending upon the question. Hope you enjoyed this session. Thank you all.